Good morning, ladies and gentlemen. This is Mr. Smith, and this is 6.1, the Pythagorean theorem. Now, you should have learned Pythagorean theorem back in grade 8. If you haven't, don't worry. That's why we're going to go over it again in grade 9, just to make sure that you're ready for grade 10 and 11. This is something that you'll see every year throughout math from this point forward. So the Pythagorean theorem is a relationship that is true for all right triangles. And if you remember what a right triangle is, that is the triangle with a right angle. So just the right triangle is what we call them. And it's used to determine the length of the third side when the other two sides are known. Now, this third side could either be the hypotenuse, which is the longest side, or it could be one of the other two sides. It doesn't really matter as long as the other two sides are known, we can figure out the third side. Now, the actual Pythagorean theorem has a lot to do with these letters A, B, and C, located here, here, and here. And C is always going to be the longest side. It's also the opposite side of the right angle. And when I say the opposite side of the right angle, I mean it's not touching the right angle. Notice how B is touching this right angle and A is touching this right angle? Well, that is because they're not the opposites of it. C is, and that's why it's not touching the right angle at all. Therefore, it's the hypotenuse. So that's the important part. And our Pythagorean theorem actually looks something like this. A squared plus B squared equals C squared. Now, C squared is always going to be your hypotenuse. And normally, if I was teaching this in person, I would click on the water demonstration and it would take you to a video. Because I don't want to get copyright striked, I'm just going to include a link to it on Google Classroom. You can click on it from there. It is a great demonstration that shows you how this works. It shows you the area of A squared and B squared is actually equal to C squared. And it's just like a proof just to show you that it's true. So A squared is this side squared. B squared is this side squared will equal C squared. Okay. With that said, let's move on to the next slide. Next, I just want you to identify the hypotenuse of each right-angled triangle. So let's look at example A. In example A, which one do you think is the hypotenuse? Just take a guess. I'm not going to dock marks if you get it wrong. If you said 13, you are correct. 13 is the hypotenuse because it's not touching the right angle. Now, we can rotate right angle triangles, and that's what we see in our next two examples. So in example B, which side do you think is the hypotenuse? 12, 15, or C? If you said C, you're correct because it is the opposite of the right angle. If you look, the right angle kind of points in a direction, and I just drew a dashed line over to that side. Okay, example C. Which side do you think is the hypotenuse? A, 6, or 8? Remember, the hypotenuse is always going to be the opposite of the right angle triangle. If we look over here, the opposite of the right angle triangle, we dash it out, goes to 8. So 8 is our hypotenuse in this case. Now, this is a basic skill that is going to be needed in order to complete the algebraic expressions later on. Here we have determined the unknown side length down to 2 decimal places. And in this case, we're just using Pythagorean theorem. We're going to be using it each time. I'm going to write it at the top of the page. A squared plus B squared is equal to C squared, just so we have a quick reference guide. And remember, C squared is always going to be our hypotenuse, which is our longest side or the side opposite of the right angle. Longest side will always be the opposite of the right angle, so just keep that in mind. All right, so we're looking at example A over here, and let's label this triangle ABC. Now, A and B don't really matter as long as you get C in the right spot. So which side would be my hypotenuse? Well, it'd be the unlabeled side. So I'm going to label this C for my hypotenuse. Then I'm going to put A and B here. You could mix up A and B and the math will still work out. Just because 6 squared plus 3 squared is still going to equal 3 squared plus 6 squared. So the math will work out, and if you want to see that, we can go over it one-on-one. But for today, we're just going to go with 6 squared, because that's what A is, plus 3 squared. Oh, I don't know what happened there. Plus 3 squared is equal to C squared. Now we just need to solve for C. Well, 6 squared is just 36. 3 squared is just 9. And it's still C squared. We can't get rid of the C squared yet. 36 plus 9 is just 45 equals C squared. And to get rid of the squared, we just take the square root of both sides. So if we take the square root of both sides, what happens is the C squared cancels out. So square root of 45. I'm not plugging it into my calculator yet. Whoopsie. So I'm not taking the square root yet. I'm just writing square root of 45 is equal to C. So there's my C there. Square root of 45 is, to do 2 decimal places, 6.71 centimeters equals C. Remember, it's centimeters because our example is centimeters. And the next one, I'm going to use different colors. I'll use blue. Okay. In our next example, so example B, we need to remember label first, then do your calculations. And it doesn't really matter where A and B go, but C is hyper important. As long as we can get C to the right one. If we look, this square kind of points to this direction here. I usually use a dashed line. I don't know why I did an arrow this time. But there's C, so that's our hypotenuse. Again, C is our unknown. And then I can say A is the bottom one this time, and B is the vertical one. Doesn't really matter. When you calculate it out, it all works out nice in the end anyway. If I'm color coding this, though, I should really use like green for B, just so you can see easier where these numbers are coming from, and maybe red for A. So I'll have 12 squared plus, and in green, 5 squared equals, and then in blue again, C squared. Perfect. So now you can see where all these numbers are coming from. 12 squared and 5 squared, if you put 5 squared plus 12 squared, it's going to be the same in the end anyway. So it doesn't really matter too much on that front. I'm going to switch my ink color over to black. So 12 squared becomes 144. 5 squared becomes 25. And C squared stays the same because we can't take the square root yet. We add these two together, we get 169 equals C squared. Then we take the square root of both sides. Now when you do this, you can choose to write this line. You can choose whether or not you want to write square root of 169 equals C. The reason I do it is because I want you guys to see where this is coming from. And the way you do this is different depending on your calculator. Your calculator, you might have to press square root, then 169. Other calculators, you have to press 169 and then the square root button. Now I'm going to ask you what is the square root of 169, and use your calculator to do this, because then you can check to see and make sure you know how to use it. If you said the square root was 13, you are correct, and the units are centimeters, so don't forget your units. 13 centimeters is C. All right, our next example. Remember, we need to label C first, then A and B. It doesn't really matter where they go. The math will work out in the end. In this case, we have C is actually going to be 5.2. So we're given C this time. And let's just say A is over here, B is the base over here. And now I can just plug these all in. So I have 2.4 squared plus, well, I don't know what B is, so it's B squared equals 5.2 squared. Now I'm going to square everything, and I end up with 5.76 plus B squared equals 27.04. Okay, now we just need to solve for B, and the way we do this is we actually have to move over. Let's use blue for this. This over here has to go over here. And remember, when we move something over to the other side of the equal sign, it becomes negative. So we'll have B squared equals 27.04, subtract 5.76, and we're left with B squared equals 21.28. And because I'm running out of room, I'm going to write it back up here. 21.28. Then we're going to end up with B equals the square root, because we're taking the square root of both sides, 21.28. And that is just B equals about, because we're rounding it, 4.61 centimeters. Yeah. Don't forget to take the square root of both sides when you do that. That's where a lot of students forget the last step. Last step is always taking the square root. Okay. Next example. Let me switch the color over to black again. And we're going to label the sides. We have, well, if we look the opposite side here, this is C here. And then let's say this is B and this is A, because we already solved for one where we didn't know B. In this case, let's say we don't know what A is. Well, it just starts out the same way as it normally would. You have A squared plus whatever B squared is. Well, that's 8 squared equals 25 squared. So then you're stuck with A squared plus 64 equals 625. It's getting a little difficult to write on this. Just give me a second. Now I'm going to move the 64 over, and that's going to become negative. So I am with A squared equals 625, subtract 64. Then we get A squared is equal to 561. Take the square root of both sides, and A is equal to 23.69 centimeters. There we go. All right, that's Pythagorean theorem. That's pretty much all the basics that you need to know. This we are going to build off of when we're dealing with perimeter, so make sure you learn this. If you have any questions, make sure you ask before the due date, hopefully. And good luck.